Banned pesticides found in clouds, sparking new health concerns. Written by Pamela Ferdinand. Key findings. Pesticides, including 10 banned in the EU due to health concerns, were detected in every cloud sample above France. 2 samples exceeded Europe's drinking water safety limit. Clouds carried not just pesticides but also emerging contaminants and new breakdown products. Most pollution came from long-range pesticide drift, not local farms. At any given time, French clouds may hold 6 to 139 tons of pesticides. Pesticides banned years ago in the European Union are drifting through the skies and turning up in clouds above France, raising concerns about how long these toxins persist and how far they can travel, with potentially harmful global health impacts, according to a pathbreaking new study. The research published this week, September 8th, in Environmental Science and Technology, is the first to detect dozens of agricultural chemicals, including insecticides, herbicides, fungicides, and other substances suspended in cloud water droplets. That means pesticides not only linger in the environment, but also move through the atmosphere and fall back to Earth in rain or snow, sometimes at levels exceeding European safe drinking water limits, the research suggests. Clouds, once seen as passive carriers of water, are now recognized as active players in chemical transport and transformation, with direct implications for ecosystems, drinking water, and public health. Pesticide contamination is a growing and alarming concern for both the environment and human health, the researchers say. Widely used in agriculture to control pests and disease carriers, pesticides undergo extensive long-range atmospheric transport in the gas phase, in aerosols, and, as shown here, in clouds. The implications for public health are stark, especially at a time when agricultural pesticide use has increased dramatically, and the industry continues to shape pesticide policy in the U.S. and elsewhere. Most recently, the Make America Healthy Again Commission report under the Trump administration advanced industry priorities by backpedaling on pledges to reduce pesticide use. Pesticides such as atrazine have been linked to a wide range of potential harms. They include childhood and adolescent cancers, neurological disorders, and a range of reproductive, respiratory, metabolic, and developmental problems, from infertility and premature birth to Parkinson's disease and type 2 diabetes. The study found that clouds can carry current-use pesticides, long-banned compounds, and emerging contaminants, industrial chemicals that either build up in the environment or form when older pesticides break down. Some even transform into new compounds in the atmosphere itself, beyond what regulators have known to consider. Researchers estimate that French skies alone may contain anywhere from a few tons to more than 100 tons of pesticides at any given time, most carried in from distant sources. With pesticide use continuing worldwide, they argue, the problem extends well beyond national borders and local farming practices. Clouds as unexpected reservoirs of toxic chemicals. This is the first time scientists say they have directly measured such a large number of pesticides in cloud water high in the atmosphere, well above the immediate influence of local farms. Clouds contain tiny liquid droplets that can trap pollutants like pesticides and later deliver them back in the form of rain or snow. Clouds also act as chemical reactors. The study found that they not only transport pollutants but also transform them into other substances. An upcoming study by some of the same researchers shows, for instance, that triphenyl phosphate, TPHP, a toxic chemical used in plastics and flame retardants, turns into other chemicals, including diphenyl phosphate, DPHP, in about 90 minutes in cloud water. To capture the data, the researchers collected cloud water samples during late summer 2023 and spring 2024 at Puy de Dôme, a mountaintop observatory and research station in central France, which is uniquely positioned to study the chemistry of the free troposphere, the part of the atmosphere above local ground-level influences. The site is part of European and global monitoring networks, including aerosols, clouds, and trace gases research infrastructure, ACTRIS, and the World Meteorological Organization's Global Atmosphere Watch. Out of 446 possible chemicals screened, including pesticides, biocides, compounds that kill harmful organisms, additives, and transformation products, breakdown products of pesticides, Researchers found 32 different compounds in cloud water. The list included herbicides, 9, weed killers, insecticides, 7, chemicals targeting insects, fungicides, 3, used against crop fungi, biocides, 1, agents that kill harmful organisms, additives, 3, ingredients added to pesticide formulations, transformation products, 8, byproducts formed as pesticides degrade. Cloud water also contained emerging contaminants, including anthraquinone, a bird repellent that is also formed during combustion and from the degradation of polycyclic aromatic hydrocarbons. PAHs in the atmosphere appeared in every sample up to 93 Yang/L. Benzotriazole, used in fungicide production and widely in plastics and detergents, appeared in 4 samples. Although it is an intermediate chemical in fungicide production, it is also commonly used in other industries as an anti-corrosive, plastic stabilizer, and detergent additive. Because of its broad use, it has already been detected in snow, aerosols, and surface and groundwater. 24-dinitrophenol, a volatile chemical once classified as a pesticide by the U.S. Environmental Protection Agency, EPA, that has since been banned. Listed as a priority pollutant, it was found in 4 cloud water samples at concentrations up to 2 micrograms per liter, much higher than the drinking water limit established by the European Union, EU. Pesticide levels were higher in late summer than in spring, with half the samples exceeding 0.5 micrograms per liter, Ng/L, the European drinking water limit for all pesticides combined, the researchers say. Even when 24-dinitrophenol, which can form through photochemical reactions, was excluded, 2 cloud samples still surpassed that threshold. Some detections involve chemicals still authorized in France. For example, the herbicide mesotrione reached concentrations up to 620 nanograms per liter, Ng/L, while the insect repellent DEET appeared at 63 Ng/L. But 10 of the detected compounds were active ingredients or metabolites of pesticides banned in the European Union. They included atrazine, banned in 2003, carbendazim, 2008, and insecticides such as DNOC, fipronil, carbutylate, and permethrin. Also identified were the fungicide tolofluinid, 2022, and a breakdown product of amitraz, 2004. The herbicide metolachlor, banned in France after being linked to widespread groundwater contamination, was detected in 3 cloud samples, even though its successor, S-metolachlor, was banned mere months after sampling. Researchers say the presence of these older, unauthorized compounds underscores the role of long-range atmospheric transport. Chemicals may be drifting into France from other countries, where they remain in use. The presence of pesticides in cloud water suggests the importance of in-cloud washout, the process by which pollutants are absorbed in cloud droplets, where they can be present and transported, the researchers say. Moreover, it raises the question on the environmental and toxicological impact of pesticide transformation in the aqueous phase of clouds, as already observed for other anthropogenic, human-made, and biogenic, naturally occurring compounds. Tracking the drift. How pesticides reach the skies. Where the air came from mattered. The most contaminated cloud samples had passed over cropland during peak spring seasons. One late summer sample, for instance, originated over the Atlantic Ocean but crossed western France, accumulating pesticides along the way. It contained 1.45 milligrams/L of total pesticides, nearly 3 times the EU drinking water limit. Another sample traced partly to Spain and French farmland also showed high concentrations. By contrast, spring samples showed much lower levels because their air masses spent most of their time over the Atlantic Ocean or forests. 2 intermediate samples picked up pesticides while traveling over croplands in France and Ireland. Local sources played little role. Only 1 sample spent more than 5% of its time near the Mountaintop Research Observatory itself, and the chemical fingerprint in the clouds differed sharply from nearby rivers and streams, which were dominated by metolachlor and its breakdown product metolachlor, ESA. Local waterways contained little or no contamination, confirming that the pesticides found in clouds were not due to nearby spraying. Comparisons with past studies of aerosols, tiny airborne particles, added another dimension. Dozens of pesticides have been found in aerosols across Europe, especially near farmland. At Puy de Dôme, however, only 8 overlapped with cloud detections. 2 pesticides, fipronil and cypermethrin, were found only in clouds, suggesting that cloud droplets capture and retain chemicals differently than dry airborne particles. The comparison also highlighted how pesticides may chemically change inside cloud droplets. Several pesticide transformation products, including breakdown compounds of toluene, fipronil, amitraz, prothioconazole, and terbutaline, appeared in clouds, but not in aerosols. Public health is at stake, especially for children. Globally, about 2.6 million metric tons of active pesticide ingredients are used each year. When sprayed on fields, as much as half can drift into the air immediately through wind or evaporation. Many are semi-volatile organic compounds, SVOCs, able to shift between liquid, solid, and gas states. This allows them to cycle repeatedly through the atmosphere in a process known as the grasshopper effect, evaporating, traveling long distances, settling back to Earth, and then re-evaporating again. Recent studies have also found a wide range of pesticides in the air. Older organochlorine insecticides like dichlorothienyldichlorophyllene, DDE, the breakdown product of banned DDT, and endosulfan, organophosphates such as chlorpyrifos and diazinon, and modern herbicides and fungicides like glyphosate and chlorothalonil. Many appear in PM2.5 fine airborne particles of 2.5 micrometers or less that can penetrate deep into the lungs. The EU Sprint project, 2020 to 2025, also found pesticides virtually everywhere: soil, water, crops, dust, and even in people, often as chemical mixtures or cocktails. These mixtures sometimes included banned substances and usually produced more potent effects than single chemicals, especially in sensitive species such as earthworms or laboratory mammals. That project concluded that real-world exposures are more complex and hazardous than regulations currently recognize. The health risks are clear. Pesticides can settle into homes, playgrounds, sports fields, nature reserves, and urban spaces, where they contribute to chronic exposures already occurring through water, soil, and food. Children, whose bodies are still developing, are especially vulnerable to pesticide exposure, and people living or working near farms face the most immediate risks. But the French cloud study shows that no one is entirely protected. Meanwhile, in the United States, pesticide regulation remains looser than in Europe. Regulators address pesticides individually, and most are exempt from drinking water rules unless specifically limited by the Environmental Protection Agency, EPA. Unlike Europe, the U.S. has no overall cap on the total concentration of pesticides in drinking water, and industry lobbying has also weakened reform efforts. The researchers in this new study suggest their findings are a wake-up call. In their most polluted sample, clouds could hold about 139 tons of pesticides, roughly 0.2% of France's annual pesticide use. Other samples ranged from just under 4 tons to more than 110 tons. Cloud tops varied from 2 kilometers over Normandy to as high as 9 kilometers over eastern France, showing that pesticides can be distributed across multiple layers of the atmosphere. The researchers caution that these are rough estimates from a single site on single days, but they stress that the quantities are significant enough to warrant urgent attention. In France, with clouds of varied origin, the pesticide concentration is not the same throughout the air column, they say. That could mean there is more in some regions and less in others, but more research is needed. These results provide the first estimate of the pesticide quantity in cloud water, which may be significant, the study concludes. They stress the need for further measurements of pesticides in the cloud. Reference: Bianco A., Nibert P., Wu Y., et al. Are clouds a neglected reservoir of pesticides? Environmental Science and Technology. Published online September 8, 2025. doi:10.1021/ax.est.5C03787.